This is Rohini Mirgu from Walchand Institute of Technology, Solapur, talking about polarization measurement. For an antenna polarization, how we can measure this polarization. At the end of the video, you will be able to measure the polarization of a given antenna. Now, as we are talking about polarization, let us talk about what is meant by polarization. Polarization is nothing but a property applying to a transverse waves for their geometrical orientation of the oscillations. The transverse wave is in the transverse wave, the direction of oscillation is perpendicular to the direction of motion of the wave. So polarization of electromagnetic wave refers to the direction of the electric field. Like here, there are different types of polarizations: linear polarization, circular polarization, and elliptical polarization. In linear polarization, the fields oscillate in a single direction. As you can see, this field is oscillating, or this is the electric field, which is oscillating in the horizontal direction. The wave you can see in red color, which is oscillating in horizontal direction, so it is called as horizontal polarization. The wave shown in green color is oscillating in vertical direction, so it is called as a vertical polarization. Circular and elliptical polarization, where fields rotate at a constant rate in a plane as the wave travels. In circular polarization also, there can be a right-handed and left-handed circular polarization, at LHCP and RHCP. So this is a left circular polarization, where you can see the circle. In this circle, this wave direction, if I see, the oscillations are along the clockwise direction. When the oscillations are taking place along the clockwise direction, then it is forming a circle around over a plane, but as it is in the clockwise direction, it is called as a left-hand circular polarization. If this variation is again forming a circle, the oscillations are forming a circle, it's a circular polarization, but the oscillations are taking place in the anti-clockwise or counter-clockwise direction, then it is called as a right circular polarization or right-handed circular polarization. In elliptical polarization, as you can see, it is the polarization of the electromagnetic radiations such that the tip of the electric field vector describes the ellipse. So this is the elliptical polarization. How to measure the polarization of an antenna? The rotation can have two possible directions. If the field rotates in the right hand, then it is called right hand polarization, and if the field rotates in the left hand, it is left hand polarization. That is okay. But how to measure the polarization? For that, this is a simple arrangement shown here. The test antenna provided with some source or the supply, whereas here is another linearly polarized antenna used as a receiver, and the received power is recorded. How it is recorded? When it is recorded, we are rotating the antenna along the particular axis to measure, or before recording this readings, we are rotating the antenna along the x-axis. So let us see here. Suppose that the test antenna is vertically polarized and the receive antenna is also vertically polarized, then rotation angle is 0 and both the antenna's polarization is matched, and our output will be like this. When this output is like this, the left hand side is the rectangular plot and right hand side is the polar plot. Depends on which plot you are plotting. From this you can understand the polarization is the vertical polarization. Now, if the test antenna is horizontally polarized, and here on the receiving side, if you are again rotating the antenna and if you are taking the readings, and if your receiving antenna gives the plot like this, you understand that it is the linear polarization. But from the polar plot, you can understand that this kind of polar plot will give the output. This kind of polar plot will be obtained when there is the horizontal polarization. So in this case, the antenna's polarization need to be matched. The receiving antenna should also be the horizontally polarized in this case. Linear polarization, in this case, the shape of the resulting measurements are same, but the peaks of the received power occur at the different angles. So we know that when the test antenna is linearly polarized, the received power will resemble the shapes as shown in the figure A and B, and by determining the angle in which the received power is at the peak, we can determine the linear polarization. For circular polarization, when the test antenna is circularly polarized and our receiving antenna is linearly polarized only here, and we are getting something like normalized output. If I plot something, this kind of a plot we get on the linear scale, but if I plot it on the polar plot, I'll get some circular kind of result. So that indicates that the antenna is circularly polarized. Now, but this will not indicate whether it is left hand circularly polarized or right hand circularly polarized. Oh, so for that, the simple approach is used where we can use the idea like when the result is recorded, the measurement is performed again with the receiving antenna, that is left hand circular polarized. Once I understand that my antenna is circular polarized, I replace my receiving antenna with the left hand circular polarized antenna, and I see if my output is maximum, then I can conclude that the test antenna is left hand circular polarized, and if my results are less, then I can check by taking the right hand circular polarized antenna at the receiving end, and I can then verify whether it is giving the maximum output. If it is giving maximum output, then I can say that my antenna is right hand circular polarized. So you can, same thing is written here. By selecting the polarization sense based on the output power that is larger, the sense of rotation for the polarization can be determined, whether it is left hand or right hand. The difficulty is that it requires the two antennas at the frequency of interest that are closely right hand or left hand circular polarized, but at which is not always possible. In the elliptical polarized, if I consider my test antenna is elliptically polarized, and if I assume that it is 45-degree elliptically polarized with the axial ratio 3 dB. Axial ratio is nothing but the ratio of the maximum, as you can see here, peak output, minimum output power. So here if I may see that the peak output is 1 and the minimum output is 0.5, so that ratio goes to be 2. If I convert in decibels, this is 3 dB. So I can say that the axial ratio is 3 dB. So if that antenna is the test antenna, if I assume, so my resulting plots will be like this, and from this plot I can understand that my test antenna polarization is elliptical. These are the references used for preparing this video. Thank you.